Hi, everybody. Today we are solving radical equations. Let's do it. All right. So the title for today is solving radical equations. We're going to do 4 examples. There's also 4 steps. So we'll make it happen. The first step is to isolate the radical on one side of the equation, right? So remember, isolate means to get it alone, right? Like we're all isolated in our houses right now. So we want to get the radical by itself. We're going to raise it to a power to get rid of the radical, right? So if I have a square root, I'm going to do a square. If I have a cube root, I'm going to get rid of it by using a cube like that. I'm going to solve the equation, and then I'm going to check for extraneous solutions, right? We'll talk about extraneous solutions on number 2. All right, so this is our first example here. We're going to be working with this problem. Here are our 4 steps. So the first thing I want to do is isolate. I want to get the square root by itself. I see that there is a 2 being multiplied, so 2 times the radical plus 1. So I'm thinking about this like 2x plus 1 equals 7. What would I do first? I would subtract 1. So I'm going to go ahead and do that. Subtract 1, I get 2. Square root x plus 2 equals 7 minus 1 is 6. All right. After I got rid of the 1, I would then divide by 2 to get the x by itself. I'm going to do the same thing here. I want to get this by itself. So I'm going to divide by 2. And I get square root x plus 2 equals 3, right? So I've done my first step. I got the square root by itself, right? That's what I wanted to get by itself. So now the next step that I'm going to do is take it to a power. So since this is a square root, the inverse of that is a square. So square root and square are opposites of each other, right? What I do on one side, got to do on the other. So I have square root and square cancel. Just x plus 2 is equal to 3 squared, which is 9. All right. So I've done step 2, all done with that. My third step is to solve it, right? So I want to get x by itself. Go ahead and subtract 2 on both sides. I get x equals 7, right? So I've solved it. I think my answer is x equals 7. I do, however, still need to check it, right? So I'm going to take this 7, and I'm going to put it into the equation right here, wherever there's an x. So I would have 2, 7 plus 2 plus 1, and hopefully that equals 7. Let's quickly check. 7 plus 2 is 9. Square root of 9 is 3 times 2 plus 1. 3 times 2 is 6. Plus 1 would be 7. 6 plus 1 is 7. Does indeed equal 7. So I know that 7 is a correct answer. 7 is a correct answer. If this part seems like a lot, you can put it into your calculator. I'll show you how to do it on Desmos here. You can actually, I'll show you 2 ways. So you have 2 parentheses, I'm replacing that x with 7 plus 2 plus 1. I can type in the whole thing and I get the number 7, which is what it's supposed to equal, which is awesome. If I want to, this is kind of cool. You can put x in here like this, and you can actually like write this out, and then you can say x equals 7, right? Then when you look at your graph, you can see here is your green line here. That's representing this side of the equation. And x equals 7, that's your purple line, straight up and down, right? Vertical line. And you can see this point right here, right? That point is 7 comma 7. So you would know that your answer is correct at 7. Kind of funky to do it this way. I would recommend just plugging in the number that you think x is and double checking that it equals this. Cool. That's number 1. Let's try number 2. Same steps. Same steps. So first thing we need to do is isolate, right? Isolate. We want to get the square root by itself. I have this plus 5. It's not a part of it. So I'm going to go ahead and subtract 5 on both sides. Gives me a square root 2x minus 1 equals a negative 3. 2 minus 5 is negative 3. That's my first step. Second step, take it to a power. Opposite of a square root is a square. I do that on both sides. square root and square cancel. 2x minus 1 equals -3 squared. -3 times -3 is positive 9. Right? Positive 9. So that was my second step, taking it to a power. Third step, solving, adding 1. 2x equals 10 and dividing by 2. Right? X equals 5. I think my answer is x equals 5, but I do still need to check it. So I'm going to take this 5, plug it into my x right there. Right? So I have the square root of 2 times 5 minus 1 plus 5 equals 2. Should equal 2. We're checking here. Right? So this is our checking step. I'm going to go ahead and plug this side in my calculator here. So I have the square root of 2 times 5 minus 1 and then plus 5 at the end. My calculator tells me that this is 8. Does 8 equal 2? No, 8 doesn't equal 2. So that means that 5 is what we call an extraneous solution, right? 5 is an extraneous solution. So there is actually no solution to this problem, right? There's no solution. If I was to plug in this equation, right, if I was to say square root of 2x minus 1 plus 5, I can see that it creates this line here. And I want to know when that equals 2. Like, when does that equal 2? Y equals 2, right? And you can see that the blue line never equals the red line, right? There's no place where they cross, and therefore there's no solution, right? So no solution is going to look like this. Mathematically, while I'm doing this, right, if you don't trust a calculator, we can do this in our heads. We have 10 minus 1 would be 9. Square root of 9 is 3 plus 5, right? That equals 8. 8 does not equal 2, so this problem does not check out. When it does not check, when we plug it in and it doesn't check, that means that there are, that solution is extraneous, right? So it means that it doesn't count as a solution, okay? All right, we'll keep working on it. Let's see, number 3. Number 3 we see is slightly different, has these square roots on it. Since there are 2 square roots, we're going to square both sides, which is great because one side, what we do on one side, we have to do on the other. So square root and square will cancel, square root and square will cancel. We'll have 2x minus 1 equals x plus 1, like that. Go ahead and add 1 on both sides. Subtract x on both sides. I won't do it all at the same time. All right, so we have 2x equals x plus 2. Go ahead and subtract that x over to the other side. 2x minus x would be x equals 2. X equals 2. Remember that I still need to check this, right? Because as we saw in the last one, they don't always work, right? So I'm going to put it into both locations here. So square root of 2 times 2 minus 1 should be equal to square root of 2 plus 1. 2 plus 1, square root of 3. This should be 4 minus 1 is square root of 3 equals square root of 3. Those things are true, and therefore I know that 2 is my correct answer, right? 2 is a correct answer. We don't have to be worried that's not extraneous, right? So 2 is our correct answer. All right. If you want to see this graphically, you can plug it in. We could say square root of 2x minus 1 and square root of x plus 1. And we can see that those cross over each other right here. And that is my solution right there. There's my 2. And that number right there actually is the square root of 3. Pretty cool. All right, let's do one more for my regular humans. All right, we've got this one looks like this. We notice there's a cube root here. We're going to follow the exact same steps So first step is getting the cube root by itself, the radical by itself. I'm going to subtract 1. So I have a positive 1 here. It's going to give me negative cube root of y minus 2 equals negative 4. This negative in front here is like negative 1 in front, right? So I'm going to go ahead and divide that negative 1 on both sides. So I'd have the cube root of y minus 2 equals positive 4. Now, here's the difference. We had a square roots before, right? So we used a square, right? We had a 3 here, so we are going to use a 3 here. We're going to cube it, right? So we're going to cube it like that. What we do on one side, have to do on the other as well. So we're going to cube the 4 as well. Cube root and cube cancel, leaving me with y minus 2 equals 4 to the third. 4 times 4 times 4, I know is 64, but we'll check it out. 4 to the power of 3, 64. I'm going to add 2 on both sides. Y equals 66. I'm hoping that 66 is the correct answer. I'm going to go ahead and plug it in there. So I have 1 minus the cube root. I'm going to go to functions, go to miscellaneous, go right here. You get 3, and then 66 minus 2. Right, and I can see that the answer is negative 3, and that is what I was supposed to get there. So it does indeed check out. This is my correct answer. All right. Awesome. All right. If you are regular or honors or star, you're finished for right now. If you're accelerated, we're going to do one more type of problem together. So accelerated only my 4th period. All right, team. So the situation is here that we may come upon. We have a square root on this side, and then we have something else over here, right? So the square root is isolated, so that first step is done. And so now I need to take both sides to the power of 2 in order to get rid of that square root. So do that over here as well. So square root and square will cancel. Negative 2x plus 30 equals, and then this squared, remember we would need to use the box. Let me give us some more room here. So x minus 3, x minus 3, x squared, negative 3x, positive 9. So when I square this, I'm going to get out x squared minus 6x plus 9. Move this out of the way. All right, so x squared goes here, 3x and 3x make 6x, 9, 9. So now I have an x squared in my problem and x's, so I need to move everything to one side. I'm going to go ahead and add the 2x, subtract the 30. So I get 0 equals x squared minus 4x minus 21, like that. This looks like something that can factor. So x minus 7, x plus 3, right? Two numbers that multiply to get negative 7, add to get negative 4. I know that's, I'm sorry, multiply to get negative 21, add to get negative 4, negative 7 and 3. So I plug those in. So x would equal either 7 or negative 3. Those are my two possible answers. I have to plug in both into the equations in order to see if they are extraneous or not. So when I plug them in here, I have square root of negative 2. I'm going to put an x here for now, plus 30. And then I also need to make sure that it's the same as x minus 3, right? So I can see that one of the solutions looks like it's going to be good, but it doesn't look like there's another solution. So I think one of these is probably extraneous. So I'm going to plug in 7 here. When I plug in 7 there and 7 here, I get 4 and 4. So 7 looks like it is a possible solution. If I plug in negative 3 instead of 7, oops, this should be 2, negative 3, And then if I plug in instead of 7, -3, I can see that when I put the square root side would equal 6, and then non-square root side would equal -6. So these do not match. So therefore, this one is not a solution. This is extraneous, and there's only one solution here. Okay, so it is possible to get like 2 solutions in one of them. You can also have 2 real solutions. You can also have no solutions if both of them are extraneous. So check it out. That's why we want to check our work. All right, team. Sounds good. See you in class.